Hey, this is Matt Dixon with Front Range Systems, and welcome to the office hours. We're going to cover today unit testing with C#, how to effectively test web and Windows applications. And with the web applications, we're going to test Web API and regular MVC. And then with Windows applications, we're going to test WPF. So I started Front Range Systems to help organizations meet their technology goals. I used to be a full-time employee, and I felt like I was always focusing on things that I didn't want to focus on, like why I needed approval for access to a certain system or something like that. So I focus now on helping companies develop software. I've been developing professionally since 2000, and I've used .NET since beta 2 of its initial release. And when I'm not at my computer, you'll find me mountain biking or at my son's hockey game, so that keeps us pretty busy. Here are a couple links here, LinkedIn and our website, so you can check us out and connect with me on LinkedIn. So here's a brief overview. We're going to discuss why unit tests are valuable. I know a lot of times people want to write unit tests, but really have difficulty understanding the value of a unit test. We're also going to cover what makes a good unit test and conversely what makes a bad unit test. We're going to write some unit tests, and we're going to show how to test web applications. Like I said previously, it's a Web API and MVC applications. And then we're going to test a WPF application. And then we'll touch briefly on test-driven development, mocks, and dependency injection. So the value of unit tests. Why do we want to write unit tests? First thing comes to mind is it ensures a decoupled design. When you're testing a class, you cannot test that class if it has a bunch of intermingled dependencies. And that's what we mean by decoupled design. I know we've seen a lot of spaghetti code, and sometimes, when we're trying to take shortcuts, we know we're writing spaghetti code, but we really shouldn't. We really need to stop that, and we need to have good, clean code. The second item there is it's repeatable. So our unit tests are repeatable. They can be part of a build. They can be part of a gated check-in. TFS supports that. A lot of other source control systems support that. So a gated check-in is when you check in your code, it runs the unit tests, and if all the unit tests pass, it checks in your code. If not, it fails, and it won't let you check it in. That way no one breaks the build. It gives us confidence to refactor and add features. That's one of the beauties of unit testing, is you can refactor your code, and as long as your unit tests pass, you know you didn't break something. This is especially good for complex systems where you aren't really, and also when you're new, when you don't really know the system entirely. Someone else wrote it, you're trying to add a feature or fix a bug. This is a great way to help you do that with confidence. Helps new developers get up to speed. So we can look at the unit test and we can see how the code is being called. We can see what parameters are coming in, where those are coming from, and we can get up to speed on the source code much quicker. We can also address critical pieces of the application. So anything that involves your core business or money needs to have thorough unit tests. We don't want some rounding error to cause thousands of dollars a minute of loss. We want to make sure that our code is clean and it's accurate and it's doing what we expect it to. So it's a good way to fix bugs. The way that I've done that in the past, especially when I come into a system, is I write a series of unit tests, and I will write a test that will fail according to the conditions that the code is given now, but that will pass once I fix the bug. So for instance, a miscalculation, let's say it's rounding incorrectly. I'll write a test that will test against that proper rounding, then I'll go fix the rounding, and then my test will turn green. It's a beautiful thing. All right, good versus bad unit tests. Good unit tests, they only test one thing. Unit, it tests the unit, the smallest piece that we can. They are fast, so we don't want to have a bunch of external dependencies. We don't want to hit the database. That's no longer a unit test, that's an integration test. Sometimes those provide value, other times not so much. There's a lot of overhead that goes into creating those. Third item, it needs to be idempotent, meaning if you run it once or a million times or not at all, it has the same effect on the system. So if you are testing against a database, we need to initialize that and clean up after ourselves properly afterwards. Triggered by a check-in. All good systems will have unit tests that run when we check in something, and the build is automatically done, does a sanity check for us. It doesn't run any integration tests typically. Those would be run as a manual process. Part of the definition of done, if you're using Scrum, which I highly recommend, you can have that as a part of the definition of done. That's what we did on one project where we had an 80% unit test coverage per assembly average, and that was part of our definition of done. Whenever we created a story, one of the tasks was always unit tests, and it worked really well. So bad unit tests. They depend on external resources. File system, web services, databases. It's no longer a unit test at that point. It's an integration test. Sometimes those provide value, sometimes they don't, but we need to know that that's what we're doing when we do that. A bad unit test will also test more than one thing, like the intermingled dependencies. A lot of times, if we have some sort of data access call, it's encapsulated in a class. Let's say the class that we're testing uses that, like a customer service. And it will new up a customer service right in the constructor. So we have no way of controlling that interaction, what that customer service is doing at that point. Another item is it won't be up to date. How many times we've written unit tests and not kept them up to date? It's not part of the build, so we don't care. And that brings us to our last point. If we don't maintain our unit tests, we can't guarantee that our code is working the way it's supposed to. Unit tests are part of the code base. We've got to change that mentality if we want to be effective with unit tests. Okay, so the anatomy of a unit test. Here's a test that we have in the source code. And let's take a look at this. So first thing we see is there's a test method attribute. This is a test that will run under the MS Test framework. I know that because it's test method. If it were an NUnit test, it would be test. It would be the attribute. And then you notice the method is separated by underscores. I use ReSharper. You can do the same thing with, I think it's called code snippets in Visual Studio. And you can create this so that when you have a little keyboard shortcut, you write a test, and it can let you add these things. So the first thing here is the class that's under test. Here it's the math service. So if you notice it says math service test underscore, it just takes the current class name. And I follow the convention of the suffixing a test on the end of that so that we know what we're testing. Then the next section there is the method that is under test. So in this case it's divide. So we're going to test a divide method. The next thing what we're looking at is the input conditions. So in this case we're using random numbers. If we see in the first and second lines there, we have two variables named first and second, and they're getting a decimal value. And then if we notice on the next to last line, we have item under test.divide, and we're passing in that first and that second. So those are the numbers that we're passing in, and we're designating that those are going to be random numbers. And then the last section of the unit test function name is the expected result. So we expect it to divide properly and return the quotient. And there are 3 A's of unit testing. The first one is arrange. So what we're doing here is we're creating some random variables, and then we're defining the expected outcome. So we have first, and we're generating a random decimal. The variable second, we're generating another random decimal, which will not be the same. And then we have an expected outcome, and we're using decimal.divide, and we're not rounding in any way. And that's what we expect to get. Then the next A is act. So we have var actual equals item under test.divide, and we're passing in first and second as the parameters. This is what we're actually testing. So we're testing the divide method in our item under test property. We'll take a look at that in just a second. And I can tell you right now that's a math service, and it returns a decimal. and that is going to be stored in the actual variable. Then the last part is assert. So we're going to assert that the actual is equal to the expected, and that's what we have in that last line. We're using the NUnit assertions, which is provides a little bit more functionality and value, in my opinion. It's a lot more flexible, a lot more feature rich. Now in this initialization and cleanup, the test we looked at didn't have any initialization or cleanup for that particular test other than creating the math service. So let's take a look. We have MS Test and NUnit equivalents. On the left is our MS Test, on the right is NUnit, because we can all read. So the test class on the left is an attribute applied to a class, and that says this is going to be my unit test. In NUnit, it's just test fixture instead of test class. And then we have class initialize. The NUnit equivalent is one-time setup. What that does is that executes before any of the tests within that class are run. And then we have test initialize for MS Test and setup for NUnit. That will run before each test in the class. And then we have our test method or test attribute, whether you're using MS Test or NUnit, and that is our actual unit test. If we go back to our code, we can see we have the test method. That's how I know we're using MS Test. After that's done, we call our test cleanup or tear down, and that's just a method that's been decorated with that attribute, depending on MS Test or NUnit, and that will clean up any resources and get everything ready for the cleanup after ourselves so that we're preparing for the next test in the class. And then we finally have a class cleanup attribute or one-time teardown for NUnit. And what that does is it cleans up after all the tests in that class and it executes at the very end. So if we look, one-time setup executes, and then if we have, say, two tests, let's focus on MS Test. So class initialize will execute, then test initialize will execute, then test method, then test cleanup, then test initialize, then test method for our second test, then test cleanup, then class cleanup. So that's a good way for us to be able to control what happens before and after our unit test. And one thing to note is we don't care what order these tests are executed in. That's important. I know MS Test does have that capability. I would discourage you from using that because that doesn't create a very clean unit test environment. It kind of muddies the waters a little bit. So let's view and debug some unit tests. Here we are in Visual Studio. Let's just go over these projects real quick. So if you notice, we have a test folder, and under that we have MS Test and NUnit. Those are solution folders. In the project structure, it's just flat. So let's start at the bottom. We have a Windows client that's using WPF, and then a web client that's a standard MVC with Web API. And then we have our services project. So let's expand that. We can see we have an iMath service, an iPrize money calculation service, and then a couple models used for payout and prize money calculation. Then we have our concrete classes. We have our math service and our prize money calculation service, and they both inherit from those interfaces of the same name with a prefix of I. And if we look at our math service, we have add, subtract, multiply, divide. Pretty simple, just some simple mathematic functions, so we can really focus on unit testing and not focus on what it's actually doing because it's so simple. Then I have this testing framework. And if we look, we have a test base, and that is just a base class. It has a property item under test, and if we notice, we're using generics here. So test base of type T, where T is a class, and that is going to be the type of our item under test. And then it also inherits from test base without generics, and that just creates a random for us. Random extensions, I'm not going to go through this in detail, but suffice it to say we can generate random numbers, strings, dates, booleans, etc. really valuable for unit tests. A lot of times we'll have a bug in our code and we won't really notice until we flood it with some unit tests, and it won't show up all the time, but it'll show up every once in a while. Then we know there's a problem, either, for instance, a string length. We may be sending in a string length that's longer than we expect, and it could cause some issues. We can have some rounding issues or whatever. So it's a good way for us to be able to make sure that our code is bug-free. So if you notice, we have two classes here. We have MS Test Base and NUnit Test Base. So the MS Test Base inherits from Test Base. Let me just get this out of the way for us. And remember from the slides, we have our class initialize, test cleanup, and class cleanup. So we've decorated those public methods with attributes. One thing to note is all the classes and all the methods that we want to test need to be public. The testing frameworks, what they do is they use a reflection. They get the public classes with this attribute decoration, and then they get the methods with these various attribute decorations and the test or test method attribute decorations, and they will execute those. That's why it's important that we don't specify an order, because we can't assure an order with reflection. And then we have 4 methods here that are virtual so that we can override those, and we don't need to wire up with the attribute. We can just override those methods. Okay, so we have some unit testing examples. Those are good for mock, is what this covers, and we'll go over that in the next section. And then we have services, web client, and Windows client. So let's look at the services. We have our math service test. This is what we were looking at earlier. We looked at the divide with random numbers. So here's the test on line 70 that we looked at in slides. And let's set a breakpoint. And I'm using ReSharper. You can do all this with the built-in Visual Studio tools. But if I click right here, and I could say debug, and it's wiring it up, starting it up for us, and we see we're in our breakpoint. So we have our locals window. Let's hit F10, go to the next step. Now we can see our first variable is 338 and some change. Second variable, 960 and some change. This 1000 we're passing in, that's going to be the maximum number. So it's a decimal value that's greater than 0 or less than or equal to 1000. Now let's divide those. Take a look. So we're expecting 0.352 and some change. And let's take a look at what our actual is. So expected, 0.352 and some change, and actual looks identical. So then we have an assertion, and we can hit F10 again, and we didn't fail because we're still in here. Now, one thing to note is we can dive into all this. We don't have to, so if I right click, hit the letter X, we can set that to the current step. Let's step through it again. So item under test.divide, let's hit F11 and we'll step into. If we notice, we are now in the math service class, and we're in the divide method. That's exactly what we would expect to happen. So we can step through that, and it's just going to return decimal.divide, get back, and our actual value is good to go. Hit F5, and it passed. We can see over here it's got a green check mark on it. That means it passed. Otherwise, it'd be a red circle. Ignored tests are with this little eye icon with a line through it. Now let's take a look at, if we go to test, and we go to Windows, Test Explorer. This is the built-in unit testing with Visual Studio. So it's right here. It's exactly the same. We can right-click, and we can debug any of these or run any of them. So we'll run it, and we should get a nice green check mark. All right. Now, one of the questions in the chat window was, what unit test coverage should we have in our projects? 100%? Well, it's impossible to get 100% code coverage. It just is. We've got all sorts of stuff in our applications that are really difficult to test. They're written by Microsoft and the .NET team, or the ASP.NET team, or the WPF team. We're pretty sure it works because our app launches, the website runs. It's kind of, the cost-benefit analysis. 100% is not worth it. 80% is a good way to go. It provides a good level of coverage without having to test things, all the minutia that really don't matter, that are written by someone else that we already trust. Now, you can also test third-party libraries, but for the most part, it provides little value to do that. Okay, so that's a simple unit test. Let's go back to our slides, and we'll go over quickly mocks and dependency injection. So if you notice our math service, it was pretty simple, 4 methods, and it was super clean. That's what happens when you write demo code. It's super clean because we're not doing anything. But mocks are a good way to keep our code base really clean like that. It removes any external dependencies, and those dependencies can be tested separately. So in our example, our math service, when we're using that in Web API, MVC, or WPF, we can mock out those references to the math service. And we're using mock, M-O-Q. And that's a pretty good framework to use. It's a NuGet package, and it provides really good functionality. NUnit provides its own, but I didn't like that one as much. It didn't seem as feature-rich. And we'll go through a demo. When we go through the next demo, we'll see how we're using mock and dependency injection. So dependency injection, it's a way to inject different dependencies. And in this case, it'll be the math service. So in our controller, in our MVC or our Web API controllers, we can inject our math service, and we use the interface, the iMath service interface that we saw earlier. So our dependency injection is responsible for generating those classes and creating concrete instances of those. So in order to do that, we need to specify a mapping between the class and the interface. We have iMath service that maps to math service. So it handles object creation, and then in our web, we have an inject web common, and in WPF, we have app bootstrapper. So let's test some web applications. We're going to cover MVC, Web API, and inject. MVC, Model View Controller. I'm sure all of you are familiar with that. Model is the data, view is what we see on the screen, and the controller is what goes and gets the data and sends it to the view. We'll also work on some Web API. We can test that as easily as an MVC controller. And we'll take a look at that. We'll run through the Web API itself, and we'll see how that's working. Ninject is what we're using for our dependency injection container. And that's also a NuGet package. And you can see how I've implemented that, and it's pretty easy to use. So let's look at a demo. Now, one thing I have to do is I have to set this as my startup project. Right click, hit the letter A, set a startup project, Control F5, start without debugging. Wait for it to load. And here's a good tool. It's called Postman. It's awesome. You should check it out. And this is what we're going to do to get our unit tests working and verify that they're working. So here's we're going to do multiply. In our body, we're sending 3.14 and 5. And we're seeing that it's 15.7. Sounds about right. It is right, but it looks right. So let's take a look at the code where we're doing that. So if you notice, we have controllers, and then I put all my Web API controllers under a Web API folder. And sometimes if you get too many of those controllers, you can segment those by folders as well. We have an API controller base. It inherits from API controller. And I just have this one method, wrap result, which creates a new result model. And the result model has one property, and that property is a decimal named result. And it wraps it in an OK response. So this will send a 200 response back to the client. And if we look, we have all sorts of stuff like bad request, not found, anything you can think of. All the standard status codes, HTTP status codes, are available there with some helper methods. All right, so let's look at our math controller. Now, if you notice in our constructor, we're taking a parameter of iMathService. Okay, that's great. Where are we getting that? Well, we are getting that. If we go to App Start, Ninject Web Common, and I said line, what did I say? Line 54. No, I did not, because it's on line 76. Here's our register services method. This is boilerplate that's generated when you install Ninject as a NuGet package. So we have kernel.bind, and then we send it a interface parameter, .to, and we send it the concrete type parameter. So this is where our binding is taking place. That's all we need to do. We need to bind our interfaces to our concrete classes. So let's go back to our controller. Ninject will create a math service for us and send it in that constructor. And then what we're doing is we're storing it in the math service property. And if you see, we've got add, subtract, multiply, divide. We've prefixed with post, so those are going to be a post HTTP, and we have a route of add, subtract, multiply, and divide. Now if we go back over to Postman, localhost, our port number, /API/math/multiply. So we've got API/math, slash is inherent, and then multiply. So this is going to go into this method here. And we're going to call the math service.multiply with our first and second properties. So let's go back over to Postman and take a look. Where are we getting that? Well, we've got body. We've got our verb as post. We're using form URL encoded. And we're passing in first. And then we're passing in second. We can do whatever we want here. I mean, we can, if we have a mismatch on the name or a typo, it'll treat it as 0. So our result is 0. And if we have additional, it doesn't really matter. It doesn't use those. It only uses the properties that are in the model. And if we look at our math operation model, we have two properties, both decimal, first and second. And ASP.NET is really good at this mapping between what's coming in and a model that it's expecting. That's obviously out of the side of the scope for this discussion, but just so you know that. So let's look at our home controller. We have an action result, and we're calling our method create math model. We have two parameters, first and second, and then it's basically just creating a model and returning it to the view. There is no view, but we're just using this for demonstration purposes. So let's look at the unit tests on that, especially that multiply method, because that's what we were doing. We'll take a look at the MS test. So here's our services test. Here's our Windows, and let's look at the web. Controllers, Web API, Math Controller test. Let's start with that one. Notice it inherits from MS Test Base. We have a test class attribute, and then in our test base we're sending up Math Controller because that's what we expect to have happen. We're testing this Math Controller. Notice we're overriding our test initialize internal method. That's in that base class. So that'll be called for every test method. So what we're going to do is we're going to create a mock math service. This is where MOQ, the mock framework, comes in. So we're instantiating that as a new mock of type iMathService. Okay, it sounds interesting. Our item under test is a new math controller, and we're sending it our math service, our mock math service.object. If we hover over that, we notice that it's returning the object properties, returning an iMath service. Okay, so I'm intrigued. Let's take a look and see what that does. For every unit test, I always like a constructor unit test to make sure our item under test is null. And if we go over to ReSharper, has this really nice feature, a continuous testing session. So if I go and comment this out and save it, we notice it's running over here. Hourglass. So all these failed because the math service is null. We remove that comment, save it, take a look at it, it's running, everything passes now. That's how we know it's working. The mantra for TDD is red, green, refactor. So we want to make sure we have a failing test to make sure that our passing test is actually doing what we expect it to do. Here's our add with a valid model, and it calls add in math service. So it calls the add method in the math service. We don't really care what the results are for this one. This is something that's a little bit difficult to understand at first, but once you get the hang of it, it's pretty powerful. So let's take a look at what we're doing. So item under test.postAdd. Remember, in our controller, we had postAdd. So that's what we're doing. We're calling that. We're just passing random numbers for our first and second properties for our math operation model. And then we're calling the math service, mock math service.verify method. And what we want to do is we want to make sure that the add method, right here on line 43, that we're calling on the math service, is being called with any decimal. We have decimal for the first one and the decimal for the second one. So it.isAny, it just verifies that it's a decimal type. And we don't care what the answer is, we just want to make sure it gets called. This is good for testing all your plumbing between your various classes. Let's take a look at the next test. This is using actual results and actual numbers, and we're expecting those actual parameters coming in and the expected value coming back. So line 49, we're newing up a math operation model. Remember, that just has two properties, first and second. We're setting them to 4 and 6. And this is the add method, so that should give us 10. Take a look for plus 6. Our expected should be that of 10. And then we're going to use our math service.setup. This is really cool. What we're doing here is we're telling mock that we expect the add method to be called on the math service. We expect a 4 coming in and then a second coming in, 6 coming in for the second parameter. So the first is 4 and the second is 6. And then we expect it to return, in this case, 10. Then a result is we go here, we call the post add. We send it the model, and we're casting it as an OK negotiated content result of type result model. Remember, that's what that web API call is returning. It's calling that wrap result, which returns a result model. Want to make sure that result is not null. That will be null if the model is of a different type, or if there was an error and it returns a different status code, or there's those are really the two situations where that would be null. Then we verify the actual and the expected numbers are the same. So in this case, expected should be 10, and our result.content.result should be 10 as well. Let's just step through this real quick and we can take a look. So we've got our locals window, expected is 0, creating a new model, First property is 4, second is 6. So far so good. And expected is 10. So we're calling our setup. Let me get rid of that window. Let's hit F10 again. And F10 one more time. So our result, when we take a look at that, content.result is 10. Looks like it worked. The result is not null. We know that because we already inspected the properties. And our expected is 10. And our result.content.result is 10. Hit F10, we're good. F5, and there we go. Okay, so as you can see, that's pretty powerful way to test our web API controllers. And let's take a look at the test for the MVC controller. So our home controller test, remember we have one method that we really care about. First of all, we test the constructor. Here's a good test. We set the viewBag property. Remember that's the standard thing for MVC web applications. We're going to set the viewBag to homepage for the homepage. Here's how we call that. We call it as our view result. And then we just want to make sure our view result is not null, and that the viewBag is not null, and that the actual title is equal to homepage. And we can run that one, and we see it's all green. Home controller test index sets viewBag title. Sounds a little less interesting. Well, what's good about that is to be able to get the viewBag, and here we're getting a view result. Alright, so here's what we really wanted to look at. We want to look at the model. So let's go back to that method and take a look at that so we can refresh our memory. So we have an action result. We have a create math model method that takes two decimals, named first and second. Basically all it does is it sets the first method, the first property, to the first parameter coming in, and the second property to the second parameter coming in. And then it returns view and passes the model. Alright, so here's our setup here. And what we're doing is we're creating some random numbers, and we have an expected model. So that's our arranged portion. Here's our act portion. Result equals item under test dot create new math model. We're sending it first and second, and then we're casting it as a view result. We're making sure the view result is not null, and then we're looking at the model. The model is of type object, so we have to cast that. We're using the as operator to safely cast it, and if that's a different type, it will come back null. So that's what we're checking for null. We're checking first and second properties are what we expect. Let's run it. Take a look over here. It's green. Notice how fast that was? I mean, it didn't take any time at all. And then one of the cool things is we can have, let's see, show time. So if we take a look over here, it took 2 milliseconds for that one, 3 for that one, 29 for that one. Pretty fast, quick unit test. That's what we want to achieve. All right, the next thing we're going to cover is Windows applications. So we're using MVVM. It's really difficult to test WPF applications without it. And if you're trying to test WinForms, that is almost impossible to test the UI. The best way to do that is to extract everything to some sort of service or helper class and test those. So in your click event handlers and things like that, you can test everything under that. If you call them something external in a different assembly or a different class, but otherwise you can't test all the other the plumbing, so to speak, in a WinForms application. So in MVVM, what we do is we test the view model, we test the model, and we test the converters, behaviors, stuff like that. So the model, to test that, one way to do that is if we're just having basic getter setters, we can write a test class that will test all of our models for us. Just get all properties using reflection with a getter and a setter, and then set it, check the value, and then get it and check the value, things like that. So that's one way to do that. No one wants to write those tests, so that's why we automate that. All right, let's take a look in our code of how we actually do that. So here, let's set that as a startup project again, and we'll do Control F5 to run it. And here is our calculator. The drop down is an operator: add, subtract, multiply, divide. So if we do 5 and 3, and then we can go through the different operators. So add is 8, subtract is 2, multiply is 15, and divide is 1 2/3. We also have this payout here, so an entry fee. This is a real-world calculation that simplified, obviously, for one of our clients. And so let's say we have an entry fee of $100 per person. This is for an athletic or sporting event. And let's say we have 10 entrants. We have a deduction amount, that's a percentage. I'll do that in just a little bit. And then we have payout places. Let's do 4. So if we notice, we can have each person gets $250. This isn't weighted. That's how the real calculation is. But for simplified purposes, everyone gets to split it 4 ways. Sponsor money. That's going to be added after the deduction. And then our deduction is 0.06 for 6%. If we notice, all these calculations happen on a fly. I'm not clicking a button for either this calculator or the payout calculation. And that's important. If we are clicking a button, that's really simple because it's just calling a method. But when we're not clicking a button, how does that work? So let's take a look at that. Here's our view model. We just have a shell view model. And before I get into that, let's look at our app bootstrapper. Remember I was talking about dependency injection? Bootstrapper base is a Caliburn micro class that's been written. Configure. We're going to set up some singletons. So we just want one of these. We have a window manager and an event aggregator. Event aggregator is a way to communicate between view models that don't need to know about each other. And then our shell view model, that's what ran at the beginning. And then here we are defining our service references. It looks eerily similar to the web API and the MVC code with the ninject. So we're mapping an iMath service to a math service. We're mapping iPrize money calculation service to a prize money calculation service. Pretty simple, and that's where all the magic happens. What we've done on previous projects is we'll use reflection because it's really easy. No one wants to write all this kind of stuff. That will go through services, get the contracts, and see what the concrete classes are. If there's only one, auto set that up for you. And then these next 3 methods are just required by the container. We're just using the simple built-in container. You can use MEF or any number of various containers if you want to change that. Let's go back to our view model. We have some private fields here. Those are for our properties. And we have our constructor. What we have coming in is an iMath service and an iPrize money calculation service. Math service is being set to a math service property, and the prize money calculation service is being set to a prize money calculation service. Then we have our list of operators here, and that's it. Pretty simple. We have various properties like our selected operator, and with Caliburn Micro, if we notice, we have an operator property, a selected operator. That's a convention. So we have our operators is bound to some sort of list, in this case a bindable collection. We don't really need that because a bindable collection, what it does is it's like an observable collection with a few more features. So when you add or remove items from that collection, it tells UI, hey, my collection updated, update your UI. And then the selected operator. So if you have operators, take off the S, prefix it with selected, that will tell it that this is an item that's selected for that collection. And if the types are the same, everything will be good. So we have our math result. As you can expect, that is where the result of the math operation will go. And then we have, this is all for the prize money calculation. And then we have our first and second property. So we're just focusing on the math one for right now. And if we notice in first and second, we're calling notify of property change. That will update the UI. And then we're calling do math calculation. That will update the value. So let's look at that method. Here we have a switch for the operator, and we just want to make sure we have an operator. If we don't want it to return anything because we don't know what the user wants to do. And then if it's plus, we call add, minus, we call subtract, etc., etc. And let's take a look at some tests. Here's our shell view model tests in our Windows client project. All right, you notice we have a mock iMath service, or mock math service here. These are grayed out because they're not being used, so we're just testing the add. We could test all the others. That might be a good exercise if you want to get up to speed on that, have some reference material. You can do the subtract, multiply, divide, and then even add another method to the add at the math service and implement that as well, implement some tests. So we're initializing our mock services. We're creating our shell view model, setting it to the item under test, and we're passing in our two mock services. If we go back to that constructor, remember we're getting an iMath service and an iPrize money calculation service. All right, here's our add, and we want to make sure we call the add service. This is almost exactly the same as the MVC test. The Web API test. We have a valid model, and we want to make sure it calls the add service with the specified values. This again doesn't really care what the answer is. We just want to make sure that that interaction between our view model and our service is in place. This next test actually tests with specific values. We notice in our setup we're calling it with first and second, and we return expected 3 and 4. That should equal 7. Another thing to note too is we can output stuff in our unit tests in console.writeLine. So if we save that, and we notice that that's the one that's running, expected equals 7, that's this right here. I'll just change this so we know that that's really where it's coming from. And it is. And those are the numbers we expect, because first is 3, second is 4, add them together, we've got 7, we're good to go. So that's very simple. That's almost identical to the other test for the Web API. Here's our constructor test, and then here's some calculate prize money tests. Calculate prize money, that'd be a good place for you guys to take a look at that. Take a look at the test, take a look at what we've done there. If we have time, I'll try to dig into that a little bit. So that's testing Windows applications. Super high level. My goal for you guys is not to dive into all this source code and go through every line, but to provide this for a reference for you guys so you can see how it's done, how things are wired up, and what makes a good unit test and what we should really be testing. So more of a research tool than go through all of it right here and now, because we only have an hour. Let's go back to our slides. Let's see what we've got next. TDD. So I mentioned this a little bit earlier. red, green, refactor. Red, write a failing test. Green, change the code to fix the test. Refactor, how do I make this code better? How can I simplify? How can I think like a software architect? We want our, here's some pet peeves of mine. Long methods, huge classes. If we follow these guidelines here, we won't have that. We will have lean methods, we'll have easy to follow classes, and everything will be nice and tidy. So test-driven development, it's really good for certain features. I don't recommend it for all software because sometimes it kind of gets in its way. This is good for anything like the calculation, the payoff calculation. Great for that. We can take a look at how we'll do that in just a second here. Let's do a demo. So if you noticed, I have here this continuous testing session. This is really good for TDD. Let's take a look at our math service test. And so let's watch this window over here. Shell VMO, we don't want that. Web API, we don't want that. We don't want examples. We want our services and our math service tests. So here are all of our math service tests. Let's just write a test that's going to fail. We're not going to implement anything at the moment. But let's say that we want to add a square method. And we want to pass in known values. So the first thing I like to do is write a failing test just like that. I know it sounds stupid, but it really makes sense because then we've got a red test, and we can see we've got our exception coming back, and we have a full stack trace. We can click on this, and it takes us right to where it's failing. Over in the left window, we have a red, like a do not enter sign, and we have that here as well as for this decorator for this function, this method. And we've got two lines here that are red. That means it failed. These three lines means it succeeded. And a gray one means it wasn't covered. We also have the same type of thing within Visual Studio. If we go to test settings, test settings, and then run test after build, every time we build, it will run all the unit tests. I like the ReSharper one a little bit better because first of all, I don't have to do a build. It'll do it for me. I just have to save the file. And it does it in the background. And it only runs the dirty tests. So if I make a comment here, save it, we notice we have a little question mark. That was a little too quick. I'll go back and we can take a look at that. So and it passes. So if I uncomment that, notice we have a question mark. And then any class that's affected by that will have that question mark as well, or any assembly. Save it, and we have a failing test. Now, the best way to implement this would be at the make sure we have the definition in the interface. So let's add that. Okay, so there's our square method. And if we notice down here, we have 2 errors in 2 files. I know that our math service needs to implement that, so let's go ahead and do that. Implement missing members. We can throw a not implemented exception. That sounds like a good idea because then we can have a failing test again. So item under test, square, and let's pass in 5. And this is our actual value. And our expected value. Okay, let's save that. We know it'll fail because we have our not implemented, and it should throw a not implemented exception. If you notice, it's running all these tests because we changed our math service. Not implemented exception. Okay, says the method or operation is not implemented. Let's take a look at our math service. There we go. Sure enough, it's not going to work. What if we do that? I think that might work. Save it. Wait for it to do its thing. And we're green. We have one error in one file. Oh, that's our view. We don't have a view for that. Okay, so there's a little TDD for us. Now let's take a look at our slides and see what we have next. Here we have some resources. We have a link to the source code and slides, and this will be sent out in an email later to everyone who attended. We have some info on dependency injection and inject on what we're using. Mocking, we have a link to the mock framework. MVVM, we're using Caliburn Micro. It follows convention over configuration. Pretty sweet. Resharper is a tool that I really like to use. Getpostman.com, where we can get Postman. And dependency injection training, we developed some training and it can be available here. It's complimentary, free at no cost. And feel free to provide feedback, anything that you think we should have covered that we didn't. And thank you so much for taking time out of your day to participate with this in this discussion.